Shall move further for the discussion of the another concept which is related to illumination engineering, that is a photometry. Okay, so photometry, it's nothing but another concept. So that is the comparison and the measurement of candle power. Okay, so photometry is nothing but here the comparison as well as the measurement of the candle power involves in this particular concepts. Okay, so that is called as a simple apparatus which is called as a photometer bench is used here. Two lamps are mounted on both the benches of the screen between them. Okay, photometry is nothing but it's a simple method used to uh, compare and measure the candle power. So candle power we have already measured using the MSCP, using the integrating sphere. So here the photometry is another technique is used to measure the candle power and also to compare the candle power here. Okay, it consisting of a very simple setup. Okay, apparatus which consisting of a photometer bench is used. This is called as a photometer bench. Okay, so and two lamps are mounted on the bench with the screen in between them. So this is a lamp 1 and this is lamp 2 and the screen is in between them. So the two lamps are placed on the bench with a screen in between them. Okay, so one lamp S may be of known candle power. Here you can say this is a known candle power S, and L is the lamp L is a whose candle power is to be determined. So we have a two lamps which is mounted on the photometer bench. This is a photometer bench. This is lamp 1, lamp 2 and the screen. So here, so S is a lamp with a known candle power and L is a lamp with a unknown candle power, or the candle power of this particular lamp is to be measured. Okay, and this is the screen. So they are placed at the distance D1 and D2 respectively. Okay, this is the experimental setup. Okay, so experimental setup is clear. So we have a photometry is nothing but it's a simple method which is used to measure as well as compare the candle powers of a lamp here. So what it consisting of? It consisting of a photometric bench. Okay, and the two lamp sources of one is known candle power and one is the lamp with we have to find out the candle power. So those two lamps are separated by the distance D1 and D2 respectively from the screen. There is a middle, there is a screen is placed. So the two lamps with one is at the D1 and one is at the D2, they are placed. Okay, the screen is moved in between the two lamps and its position is adjusted. So you can see the screen is moved in between these two lamp screens and this position is adjusted. The illumination is same on both the sides of the screen. Okay, so illumination is same on both the sides of the screen. Okay, so by applying the inverse square law you can find out the illumination here. Okay, so the screen is called as a photometer head and the photometer bench is graduated so that the D1 and D2 may be measured. So screen is measured, so the illumination intensity is measured. So by using the applying the inverse square law, you know the inverse square law, it's the illumination on the any of the surface, plane surface, is directly proportional to the square of the distance between the point source and the plane surface. Okay, so here the candle power of the here candle power of the lamp L is a D2 square. The candle power of that means S is of D1 square. So the screen is so by using this you can calculate the candle power of the, you know the candle power of your lamp L candle power, you know you have to find out the lamp S candle power. Okay, distance is also, you know, D1 is also know, D2 is also know. How much distance you have placed how much distance the lamp S is placed and how much distance the lamp L is placed, both are known factor. And also you know the candle power of one lamp, that means you know the candle power of lamp L here. Okay, you have to find out the candle power of you know the candle power of lamp S here. Okay, and you don't know the candle power of L, but you know the distance, how much distance that the lamp L is placed, and you know the how much distance that the lamp S is placed. Okay, so all the factors are known. Just substituting the distances and the candle power of one particular lamp, you can find out the candle power of the other lamp. So this method of finding out of the candle power is called as a photometry. So the sister setup which is used for this particular is called as a photometric bench, the measurement of candle power using the photometric bench or photometry. Okay, so what are the different parts of this photometric bench. It consisting of mainly three important parts of this one. So it consisting of a photometer bench. So photometer, first form very important is photometer bench. So photometer bench is nothing but it consisting of a two steel rods, okay, between 3 to 4 meter long, okay. So the two steel rods between 3 to 4 meter long, on which can be fitted, okay, the standard lamp and the test lamps, okay. It consisting of a two steel rods between 3 to 4 meter long, okay, which can be fitted the standard hold, which will holds the lamp, okay. One of the steel rod carries the brass strip with a graduated scale millimeters. One of the which consisting of a brass strip with a graduated scale that will indicate the distance between the lamp and the screen, to indicate that the graduated scale will be there, so with in terms of a millimeter. The bench must be rigid enough to free from the vibrations. The bench must be rigid, that means it should be rigid, that should not carry any vibrations, okay. And the graduations and the distance measurement must be accurate, since the calculations of squares of the distance are used, okay. So as you are using the graduated scale, so the whatever the distance measured will be very precise value, okay. If it is necessary that the no light except from the lamps under the comparison should reach the screen, so except the whatever the comparison light, so there should not be any other light radiations will fall on the our screen, okay. So the photometry room is made dark. The very important is the photometric room should be dark, okay. So and the walls and ceilings are painted with a black color. So if you are measuring any test lamp and the other lamp candle power, the room's wall should be painted with a black color, and also the ceiling is also should be in a dark color. Then only you will get the correct or a precise value of the candle power. So this is about how the photometer bench should be. So next is another important part is photometer head. So photometer head is nothing but, so quite few types of photometers heads are since we are using to measure the candle powers. So there are various photometers heads are used. So the most common in the use is Bunsen and Lumer type of the photometer head. So there are various photometers heads are there to measure the candle powers, but so the most commonly used type of photometer head is a Bunsen and Lumer Borden type of a photometer head, okay. When the lamps of the same and very similar color, let us take, you have a lamp of a same and very similar colors are compared. If you want to compare the similar color of the lamp, then your precise, your Bunsen and Lumer photometer gives a precise value, okay. So the accurate results will be obtained using this one. So there are once again flickering photometers gives the better results. So Bunsen and results, if you are using two lamps of almost similar candle power value, in that case if you are using a Bunsen and Lumer as well as flickering type of photometers, so it will gives you a precise values, okay, precise values. So what happens in the flickering type, what happens, this is consisting of a piece of a thin paper, at the center of which there is a spotlight is placed, okay, which is made by treating the paper with the oil or wax. So oil or a wax paper is placed in between that, so that is called as a grace spot photometer. So if you are, instead of this flicker type, if you are using, if you are placing a oil or a wax what is that paper, so that is called as a grace spot type of the photometer, okay. So in that case what happens, the lights falls on the paper from both the lamps. So from two lamps we are having, in between that we have a grace spot type of photometer head. So in that case what happens, light fall from the paper from both the lamps, okay. The the paper will be illuminated on either side by the lamps on the side only. So